A steel ball bearing bounces vertically on a steel plate. If the speed of the ball just before a bounce is Vi and the speed immediately afterwards is Vf, that is alpha times Vi, with alpha less than 1, draw the graph of the time between successive bounces as a function of time. So what they are saying, that there is a steel ball that falls from a certain height on a steel surface and it collides and it moves up. So just before striking, the velocity at any moment is Vi and Vf is the velocity afterwards, that is immediately the speed of bounce. This is equal to alpha times Vi. So without any doubt you can say that alpha is the coefficient of restitution, and it is less than 1. So what we have to find out is the time between successive bounces. See, moving up and then coming down, it will be how much? Moving up and coming down, that is the gap. So moving up and coming down is 2u by g, that is 2v divided by g in the nth time, is it not? Where Vn, it will be equal to alpha to the power n times Vi, because first time it strikes the ground with a speed Vi, this Vi I was trying to show, and it moves up with Vf. So therefore Vf after nth times, it will be alpha to the power n times Vi, is it not? So we have here as tau n, that is the time gap between two successive striking on the plate, it will be equal to the first time when it falls and then alpha to the power n, is it not? Here if you put this Vn, then what will happen? Put this Vn, so it will be equal to 2 times Vi by g into alpha to the power n. So ultimately that T naught or tau naught, you can say this tau naught I am writing it as 2 times Vi divided by g. Now what they are saying is the time total elapsed is, what is the total time that elapsed? The total time that elapsed will be summation of all these tau naught, is it not? So that is summation of all these tau n, n times it strikes and bounces, so it will be equal to summation of all the tau naught into alpha to the power n, where n varies from 1 to n. So tau naught is constant and summation of all the alpha to the power n. So tau naught into, it will be alpha to the power n means how much? Alpha to the power 0, that is 1 plus alpha square. It goes on up to n times, and as you know that alpha is less than 1, so this will be infinite GP with the common ratio as alpha. So I can write as tau naught into, the summation is 1 minus alpha to the power n divided by 1 minus alpha, is it not? So this we can write. Then further it will be equal to tau naught minus tau naught alpha to the power n divided by 1 minus alpha, and tau naught alpha to the power n is tau n. So therefore we have, this is tau naught minus tau n divided by 1 minus alpha. This we can write. So what is our job? Our job is to find out, that is t times 1 minus alpha, this is equal to tau naught minus tau n, and from there we can say tau n is equal to tau naught minus 1 minus alpha into t. So this is the final expression, that is how the tau n, the time lag between the two successive collision, it changes with time. Now we have to draw the graph of. Let me try to draw the rough graph which will show that how tau n varies with the time t. So in your opinion, how the graph should be? The graph will be a downward sloped, is it not? The graph will be a downward sloping straight line. So let me try to draw a straight line, the downward sloping straight line like this. So this will be the graph of the time gap between the successive collisions with time. Thank you.